Good morning, and welcome to the post-launch news conference for Space Shuttle Discovery's STS-131 mission to the International Space Station. Joining us here today to discuss Discovery's liftoff is Associate Administrator for Space Operations, Bill Gerstenmaier.
Morning.
Japan Aerospace Exploration Agency President, Kagi Tachikawa. Space Shuttle Program Launch Integration Manager and Mission Management Team Chairman, Mike Moses.
Morning.
And STS-131 Space Shuttle Launch Director, Pete Nikolenko. We'll start with questions. We'll start with opening remarks here at Kennedy and then take your questions. Mr. Gerstenmaier.
Thanks, John. It's a great day today. You got to see an unbelievably great launch. You also got to see Space Station fly overhead, which was kind of an extra special treat for us all. So, again, it's really a tribute to the team here in Florida that got the vehicle ready to go fly. They did a tremendous job of process and discovery and getting the vehicle out to the launch pad and working through some issues as we went forward. Things went extremely well during ascent. We saw maybe 3 little foam loss events all around 4 minutes or so. We don't think those are problematic. The teams will review the video some more, and that worked pretty good. We also had an accelerometer on the main engine, and Mike can talk to you a little bit more about that. And again, that was not a concern to us. It was 1 of 3 measurements. So the vehicle was extremely clean. The teams did a tremendous job of getting the vehicle ready to go fly. The mission will be a very challenging mission, as you've seen from the timelines, the activities, the MPLM work will be busy, but the crew's ready to go do it, and we'll see how the mission goes throughout. But a great start to a great mission. So thank you.
Yeah, thank you. It's my great pleasure to be here today and to be able to witness the launch, successful launch of the Space Shuttle Discovery on board, which the Japanese astronaut Mrs. Yamazaki flew. STS-131 mission is her first space flight. Her main duty during this mission is to operate 2 kinds of robotic arms. She will connect a logistic module Leonard to the ISS, then remove it and put it back. So, and inside the space shuttle's cargo bay. I am confident that astronaut Yamazaki will be able to accomplish her duty successfully as she prepared well through her hard training. Since 1992, when the first Japanese astronaut, Dr. Mori, flew on the Space Shuttle Endeavour for the STS-47 mission, 6 Japanese astronauts have left for space from the Kennedy Space Center on board the Space Shuttle, or totally 11 times. Mrs. Yamazaki will be the 7th Japanese astronaut. I cannot help becoming emotional about the remarkable progress that Japan has made in the field of human space activities with the Space Shuttle flight opportunities. Astronaut Noguchi, the 2nd Japanese expedition crew member, has been living in the ISS since last December. Astronaut Yamazaki will meet him at the ISS during this mission. For the first time in history, 2 Japanese will be in space at the same time. We sincerely appreciate the support and cooperation of NASA. Finally, I would like to conclude my remarks by expressing my heartfelt wish for a success of STS-131 mission and the safe return of all the crew. Thank you very much for your attention.
Well, good morning, everybody. It sure was a spectacular launch and a picture-perfect countdown. We had really nothing to talk about, although Pete will tell you we talked for a long time about nothing, but that tends to be our way. We had when we came into count, Pete had told me when we were getting ready to tank the vehicle about a little glip on one of the fuel cell number 2 monitoring systems. It's a measurement we call the H2, the hydrogen motor status, and so it's basically a measurement that's trying to tell us the output of the motor that's spinning to pump basically it's a hydrogen separator. So it's pulling water out of the fuel cell, pulling the hydrogen out of that water, and then spinning it around. And so it's a health monitoring of that pump. That's a pretty critical piece. If that pump floods and we don't pull enough water out, that water builds up in the fuel cell itself, floods that fuel cell, knocks the electrolyte out of its cells, and makes an unsafe configuration inside the fuel cell. So we're very interested in the health of that fuel cell. In fact, it was a measurement that was added after an anomaly seen on STS-2. So it was added as an after effect to give us a lot more insight into the health of the fuel cell. The problem is it's trying to measure the health of a pump by measuring its voltage and its current, but it's also the fuel cell itself producing voltage and current. So you're getting kind of a ratioed measurement of the health of the pump plus it's being tweaked by all the downstream loads that come on and off on that fuel cell. So anything on the AC current makes that measurement change a little bit. And so it takes a little bit of detective work to figure out why it changed and to make sure it really wasn't a pump problem, or vice versa, that it really wasn't some other problem that's being masked. And so the team talked a lot about what they could do. We did a little bit of troubleshooting, adjusted the lighting to try to see if we could induce that signature again. But when the folks looked at the high rate data, you could really see that this signature didn't look quite like we had ever seen before with a lighting adjustment, and instead it looks like an anomaly that's kind of been present on Discovery, it turns out, probably since it was built. It's shown up now. I think this is the third flight. The last one was STS-63. I think it was on STS-42, where there's just this momentary little change in current status on the motor. What we think it is a change in the instrumentation. There's some little impedance that gets into the system, makes that measurement change, drifts up high, and then it resets itself right back to normal. And that's what happened right before tanking. We never saw it reoccur again. We talked a lot about what we would do if we did see it reoccur again. The team pretty quickly came to the conclusion that it was not a safety concern. It was not an indication of the motor itself having a problem or any kind of water buildup in that fuel cell. It was an instrumentation output. We couldn't prove that to ourselves, so we stuck with the LCC as written. So if that measurement did reoccur late in the countdown and was of a higher magnitude than we saw, it would have been a no-go condition. But that never did happen. And so we did, again, we talked a lot about what we do if it happened again, got a really good story together, and the team was prepped. Pete's team did an outstanding job with that failure. Once we lifted off, on the way uphill, one of the main engines, the left main engine, the high-pressure fuel turbopump, has 3 accelerometers on it. They're there to basically measure vibration levels. So if that turbopump starts to have a problem, it'll vibrate a little bit. What happened was one of the 3 transducers got a little noise on its floor, so it elevated the bottom, the platform, basically, the noise platform, and the health monitoring system threw that out, said that's a bad sensor, and it disqualified it. So we went from a voting logic of 3 of 3 needed to be bad to shut down the engine. We dropped down to 2 of 2 needed to be bad to shut down that engine. But there was nothing wrong with the engine itself. So just this one transducer acted up, and the voting logic threw it out to say, I'm not going to talk to you guys anymore, and I'm only going to look at the other 2 good sensors. Main engine itself was perfectly healthy, no problems whatsoever in the engine, worked perfectly nominal all the way through MECO. So that was really all that we had. The crew didn't get that annunciation. That's only detectable on the ground, so they didn't even know that happened, although they reported to them post-MECO. As Bill said, we had a couple little tiny foam events late after 4 minutes. It's outside the ASTT, the aerodynamic transport time, that we're worried about, the critical time when the energy of a foam loss, if it hit the shuttle, would cause damage. So at 4 minutes, that's not a problem, and the sizes were pretty small. The folks will take a look, but first cut through, with the shuttle going up through Sunrise, we got a really good look at the tank as we went uphill, and it looked to be performing in fantastic shape. The folks at Michoud delivered us an outstanding tank. The solid rocket motors from ATK performed flawlessly. The main engines, other than that one sensor being thrown out, did their job. Workhorse engines, they've been doing their job ever since we've started flying this program. It's been amazing. And then the orbiter itself is performing flawlessly. So we got word from the folks right before we came in here that OMS 2 burn was complete. They're in a safe and stable orbit, and the crew's rapidly heading through their checklist to configure the orbiter from a rocket launch to the space plane that it is in orbit, and the spacecraft to head to the station. So I can't even begin to say how proud I am of all the folks who got us to this point by bringing the hardware together, stacking it, building it, testing it, and then today launching it, and about to happen here in the next 2 weeks, going and flying the mission and executing it. It's going to be an action-packed mission with 3 EVAs, doing a whole lot of science, and we're really looking forward to it. So that's all I have.
Well, good morning, everyone. It's really exciting and great for me to be here to report that we launched successfully on the very first attempt. I'm really, given my previous track record, I'm especially proud to have launched on the first attempt. You know, I'm really proud of this launch team who makes an extremely complex task and activity of processing and launching this vehicle look so easy, and they really did do that. As Mike said, the only technical issue we had was related to that fuel cell pump motor condition. Since we detected it prior to the start of tanking, we did take a little additional time and delayed the start of our external tank load about 32 minutes so we could do some initial troubleshooting. And then we talked to verify that, in fact, that we understood and properly were able to manage to the launch commit criteria. And as Mike stated, it held steady throughout the entire remainder of the launch countdown and through terminal count. Late in the launch countdown, the Eastern Range reported that the Jonathan Dickinson tracking station, we had some communication errors with the command message encoder and verifier between the tracking station and the Cape Canaveral Air Force Station in the control center. And what they did was they switched from one communication string to the other one, reestablished the proper command verification, and we were able to get that go. But we had a little bit of late communications with our range folks about that. But it is important for us to make sure that we have that good communications to and from that for tracking purposes for the mission. But we successfully overcame that minor hurdle. From a weather perspective, we've talked a little bit about some patchy fog, and fortunately it never really materialized. The fog over the previous few days had been a little bit worse, and fortunately all the conditions aligned properly, and weather was not an issue at all for us today. So with that, it was amazing to watch that wonderful launch, and we're looking forward to an outstanding mission, as Mike stated, and looking forward to the planned end of mission here at Kennedy Space Center on the 18th of April. Thank you.
Thanks. Before we get started, we're going to ask that you ask one question and one follow-up. If there's time, we'll go back around again, but we just want to try to get things moving this Monday morning. So please remember to state your name and wait for the microphone. We'll take one, start in the front here.
Chris Gebhardt with NASASpaceflight.com. I guess one word that comes to mind after today is just wow. And you know, great, you know, congratulations all around to you and all the teams who got us to this day. Personally, I can't think of a better way to talk about how the teams take care of these vehicles than the extremely low IPR counts, or interim problem reports, that come up on these vehicles through processing. And if I'm doing my math right, we have a new record low number set for Discovery. What was that final count? And I do have a follow-up.
Final number was 46, and that is a record.
Okay. And also on the fuel cell Toma 2 issue for Mike, is that similar to what you were seeing on the Atlantis vehicle for 125 and 129, just on Discovery, and a little different configuration this time? I'm a little unclear on that.
Yeah, it's a little different signature. It's the same sensor that we're talking about. On Atlantis, it was more of a noisy transducer that it moved around a little bit and was bouncing, and that again looked like some of the downstream loads that had some noise in them that caused an induction back up to that sensor. This was a different signature, but the same sensor, so it was similar but not the same failure, if that makes sense.
Let's go across.
Mike Schneider, Associated Press. I guess my first question is to Pete. I was just wondering, given that this was the fourth to last shuttle launch and probably the last night launch, is there, and also given the uncertainty of the future of the U.S. space program, is any sense of either reflection or nostalgia set in with the launch team?
Well, just speaking for today, everybody was just really all focused on executing the launch. I know that there was, as I was leaving from the control room to come on over here, I was noting just a lot of elation, and folks were just immensely proud and happy, and I didn't get any, not at this point at least. Certainly in the next coming days and weeks, I don't doubt that there'll be some reflection, but at this point it's all in the excitement of successfully executing the launch.
And I'd like to ask Mr. Gerstenmaier, if you could give us any preview or sense of what you expect President Obama to say when he comes down here next week. Do you expect him to announce anything new, or just reiterate what he's said before?
I really have no idea, so I've not been consulted, and I don't know anything to speculate on. So,
Bobby?
Bobby Block with the Orlando Sentinel for Gerst. In recent weeks and months, you guys have been doing some internal studies on heavy lift vehicles, and I was wondering if you could give an update of where that is and if there's any possible contenders that you see that could fit within the budget profile and fill the flexible path?
Yeah, I don't think we've got anything refined well enough to put a budget, against it or see if it fits. We've been kind of looking at just generic things to look at what kind of capabilities we need, what stuff we could put together, those kind of things. So the teams have been generically looking at things. We've also been trying to flesh out some of the flagship demonstration missions that are coming up, some of the other technology things, some of the other science things. So the team's been generally looking at things and just kind of being prepared, but there's no really specifics that we can really share or any major findings that anybody's come up with.
And is there anything, I mean, there's a lot of talk about an all-liquid vehicle. I mean, are the teams leaning in any particular direction?
Again, I think what we're doing is we're just trying to look at what mission we want to accomplish to be, have a vehicle and a system that can support multiple destinations, multiple missions for us. We're looking at what technology we have, what technology we might want to develop in the future for the nation, those kind of things. So it's pretty much a generic kind of open study, kind of look at things in a very broad sense. So we haven't really homed in on anything, haven't picked anything specific, and then, as I said earlier, we really don't have the details behind it that really put it together as a program. So it's more of kind of a just step back strategic look at what kind of things should we be looking at, how do they fit with the vision we've been given from the administration.
Greg?
Greg Dobbs from HDNet Television. Congratulations. Where, if at all, I suppose this is for Mike and maybe for Pete, where, if at all, do talks stand vis-a-vis adding one more mission to the end of the schedule, adding what would amount to a sixth flight, I should say, this year?
Let's see, we still have the manifest that we've always had, and that is that it ends after STS-133. So we fly 132, 134, and then 133. We have STS-335. That'll the SRBs will be stacked, the external tank will be here, and the orbit will be prepped. Atlantis will be prepped and ready to go from a launch on need rescue capability. But unless we have an emergency, we are not under direction to fly that mission right now. Other than that, it's a political direction from above, and I don't have any news for you that says we've been given direction one way or the other. We're still flying the manifest in front of us.
You don't have direction, but is there a contingency plan if they say, yes, you can go with one more mission?
Well, we have to be ready to fly 335 as a rescue mission. So from a program standpoint, we will be doing filling all the squares as if we were going to launch that vehicle, and we wouldn't turn it off until STS-133 Discovery was back safely home. So up until that point, we're going to be prepping as if we're going to launch that vehicle.
Would you dismiss the possibility of doing 135 without a rescue vehicle to go up after it?
Yeah, again, if I go there, I'm going to be speculating and not telling you what NASA knows. It would just be my own personal opinion, and there's no value there, so can't help you.
Todd Halverson.
Todd Halverson of Florida Today, one for Pete and one for Bill. For Pete, you mentioned the record low number of interim problem reports that were racked up on this mission. I wonder if you could tell us what you attribute that drop to, and it seems to me that there's been a real downward trend in IPRs over the course of the 18 post-Columbia flights at this point. And for Bill or Mike, I seem to see the same kind of trend with in-flight anomalies. You guys aren't really seeing a whole lot of them. What do you attribute that to, and how important is it to the mission that you don't have problems with the orbiters in flight?
Well, I'll start first, Gerst. I don't know that there's any single thing that you can put your finger on. I tell you, I am very proud of this team and how much it really proves how much diligence and professionalism that this team, collective team across the agency, puts into processing the vehicle for flight, because it just really tends to show in not only how safely and successfully we do launch, but just the few number of processing anomalies that we note both on the ground and in flight. Is there any single thing that we attribute to that? Not anything that I can think of. I mean, we have really rigid processes and standards requirements, and we tracked all of those requirements. And as I mentioned after launch, we have such a huge army of unsung heroes of folks that do that configuration management and safety and quality and other mission assurance that helps our technician and engineering workforce execute the mission and get it done right. So I think if nothing else, we're just hitting our stride and we're doing it quite effectively.
And I'd say on orbit, again, we're also seeing a very low anomaly rate on orbit. I think a piece of it is the maturity of the hardware. We've flown this hardware for a while, so we understand how it works. It's also a tribute to the team that they keep looking at stuff. They keep trying to understand things better. The helium isolation valve that we actually discovered last fall, and we didn't realize it in the data. We've now learned what that signature looks like, that it has this intermittent failure mode where it can stick open, which we didn't really understand before. So the teams have understood that. They've internalized that. They're going to go then make it even better the next time. So I think the folks have done just a tremendous job of looking ahead. We pulled the carrier panels off around the window to look at vest belt fasteners. We're still looking for things. We're working hard. We're not giving up, and that's a tribute to the team. So the hardware is mature, and the teams are continuing to work and find things. And then going back to your other question, it's absolutely critical that this vehicle performs as well as it does. If you take a look at the EVAs and the spacewalks and the timeline of this mission, it is an extremely packed mission. So the fact that if we don't have to do a focused inspection, that'll give us back 3 hours during the mission, which will be a huge benefit to us. If we don't have to troubleshoot any hardware systems on orbit, we don't have any minimum duration flight kind of issues, that's unbelievably important to us. So to succeed with the missions we've got, we need to have a vehicle that's performing just as well as the vehicles we've seen. So again, the overall team is doing an extremely great job with this stuff. It doesn't come easy. I think the danger is sometimes we start seeing that this is easy, this is not a big deal. What you saw today is a miracle. I mean, this is phenomenal. You get inside 31 seconds, you watch all the pumps come online, you watch all the actuators move, you watch all the valves do their things. It's phenomenal, and that's a tribute to the team and a tribute to the vehicles and the folks that really work these systems.
Thank you, Tarek Malik with Space.com and Space News. And I have a question, I think, for Bill and a question for JAXA. For Mr. Christenmaier, there's 4 female astronauts in orbit. There's the most Japanese astronauts in orbit. This may be the last time you have 13 people in orbit together. And I'm just wondering if you can kind of comment on kind of hitting these records now as maybe the most populous spacecraft is kind of retiring right now.
Yeah, I guess if I think about, kind of the legacy of the shuttle program, the shuttle and station program have really taught us that we can work and live in space. And this is just a piece of that, right, is that, we're seeing the 4 women on board the space station, or we will after we dock, and we're seeing the 2 JAXA astronauts fly. So we're seeing, kind of a move away from where space was a place we went to and did some things to more we're actually going to go to space to do research and do technology that can help us here on the Earth and also prepare us to go places in the future. So I think this is a natural point in the program as we're starting to transition from maybe just getting to space was the big deal. Now it's not only to get there, but we want to go do things and do research there and utilize microgravity, utilize what we've got in space to discover more things about the Earth that can actually help us here on the Earth. So we're going to get a chance to see some of that return on our investment, see some of that research come back to us. So I think that's kind of the phase we're in right now.
Thank you. And for JAXA, I'm curious how Japan is preparing for the retirement of the space shuttle and its own spacecraft like the HTV for future access to space station and possibly even future manned spaceflight. Thank you.
We have no idea for human flight, but we are now thinking to have to develop some return capability using HTV now.
Question here in the front.
Yes. Stefano Coledan with the Italian Radio and Television Services. 2 unrelated questions. Number one is, now that you have, seems like a mature system and that works and launches go off pretty smoothly, don't you feel like a sense of kind of sad irony that it's only a few flights before you have to close the program, that now you seem to have this kind of performance almost matching the Soyuz that they launch whenever they say they launch. They launch, and theirs is a system that is 60 years old almost. If you look at the design time, and for the shuttle is almost 30. And so I was wondering how you must have some reflections about this, and have an unrelated question.
Bill, I can take that one.
Okay, and I can do a piece.
Okay. The as Bill said at the beginning, this is a very complicated spacecraft, and while we do make it look easy, it's certainly not easy to do. It takes a lot of care and feeding to keep flying the shuttle safely. You look at its design; it's got some challenges in the design that make it difficult. That if we went and redesigned a vehicle like shuttle, we would probably make some different design trades in it. So while we can continue to fly it safely, and I have every confidence in the team's ability because of what you just said, we're hitting our stride. We're flying at a rate that's just about the right spacing. The teams are performing very well, and our tools and our techniques and our knowledge of the shuttle is just constantly growing. We're always learning. We have way better techniques right now than we did even 5 years ago to analyze failures and how things like foam on the tank work. So while we can continue to use it, there is some irony in the fact that we're going to shut down at the peak of our performance. Yet the reality is in the budget world that we have, we can't continue to keep doing that mission plus flying station plus go beyond Earth orbit with a new system, and it just becomes a trade at that point. And while it is painful and sad to shut down the one program that's flying, you need to do it so you can build the next program to continue on. So from that standpoint, it's bittersweet. It's tough to set it down, but I can't wait for the next thing to come along, because that's going to be the future of human spaceflight.
And I think also the mission has changed a little bit. We truly needed the shuttle capability to assemble station. Without the ability to carry the large modules to orbit, we could have never built station. Now that station's assembled and built, we can then go to a simpler vehicle that is not as quite heavily integrated or requires all the components and all the care and feeding. So we can actually design a vehicle or use a vehicle that's a little more geared to the task at hand, which is something similar to a Soyuz, where you can actually do crew transport, carry some small items up, carry some cargo up through our commercial resupply services. So again, I would say, the shuttle has done its job well. It's established the station for us. It can now be a commercial market to go push for the new commercial providers to come and carry cargo. You can take some of the lessons we learned from design a shuttle, apply those to the new vehicles, and end up with a system that's a little more designed for the future tasks at hand. So I think it is tough we're shutting down the shuttle, but it's really served its purpose. Now it's time to move to that next generation of vehicle, building off of what we learned here on shuttle. So we shouldn't put these lessons aside, shouldn't put the hardware aside, but we should take those, carry them into the next design, and build an even simpler system that's a little more easy to fly for the mission that's needed.
The other question is concerning the communication problem that you had with the RSO. What kind of command was that signal supposed to carry?
I can't speak to the details of it. All I understood was that it was that command message encoder and the verification. It was a call it a talkback, if you will, between the Jonathan Dickinson tracking station and the Cape Canaveral Air Force Station. And that's as much in the way of detail that we got. And there is a launch commit criteria that verifies that we have good those two good command message encoders and verifiers available and operable prior to launch, and they were both verified on that second communication string.
Hi, Mark Kirkman, Interspace News. This question is probably for Mike, even though you said your opinion doesn't count. But big picture, can you tell me, assuming nothing gets added to the shuttle manifest, can either you or Bill tell me how this year is going to play out? And what I'm getting at is what happens as we move along with the orbiters. Are you going to continue to process all three orbiters as if you're maintaining the fleet, or are you going to, of all the part suppliers, like if you needed a helium pressure valve or something like that, have all those vendors already been turned off? How does this year play out if it stays as it's currently cut?
Well, we've built a transition and retirement plan, and it's been in work now for any number of years, that laid out exactly that transition plan. It looked at the spares we have on the shelf, identified the places where we need to keep vendors alive, and procuring hardware, the ones where we have plenty of spares and we no longer need those suppliers. And so some of them have already been turned off in the propulsion element worlds. Most of that's all shut down. In the orbiter world, I don't know the numbers, but we've definitely turned off some of those supply contracts. Others we're keeping going because we do need to keep going. We talk about the transition plan. Right now, the general thought is that from a budget perspective, we're going to keep the fleet going, because by the time you land a mission, you do its down processing and you begin to safe it for just to safe the vehicle before you even begin to prep it for transport for display. That timeline is such that each of the vehicles won't get very far down the path before we finish our last flight. So all three will kind of be up and running. They won't be fully up processing ready for the next mission. Discovery will be the last to fly. Atlantis will be already prepping to be rolled over. So Endeavor's the one that's kind of questioning as to where it falls in the timeline as to how far we take it. If you look at the missions and we fly them per the manifest, we will have basically finished down mission processing with Endeavor, and maybe have gotten about 3 or 4 weeks into the safing phase. So we won't go very far when you actually lay out the calendars. It's not like we're going to have months and months where we sit around with an orbiter and we don't know what to do with it. So from that standpoint, we're not really keeping all three in pristine shape, but by default they're pretty much staying there just because the way the schedule works out.
Okay, and just to follow up, I hate to ask this, but does that mean the manpower will stay the same at least until the final flight, or do you see having, okay, we get to this point, this orbiter's theoretically not going to fly anymore, these X number of people are no longer required, or are you going to keep the full manning?
From an orbiter standpoint, again, the propulsion elements, the ET, the SSME, and the tank guys, they've already ramped down, and that profile's heading down pretty fast in terms of their workforce and their suppliers. In the orbiter world, we call it a step function where the processing teams and the orbiter support teams and all the hardware stays at 100% until we'll stop at the last mission. It's not exactly 100%. It ramps down a little bit, but looking at the overall picture, it's close enough to calling it kind of a step function down. So there's a small little ramp there, but it's not a very big one. And so that force stays with us pretty much until the end.
Jim Siegel, Celebration Independent Newspaper. Assuming that the President decides to continue his plan to have all of the manned flights go commercial, what recommendation would each of you have for the President to help in that transition from what we have today to an all-commercial manned spaceflight strategy? And don't.
I don't think I'm not even going to try.
I was going to say my recommendation would be from a standpoint of capturing the lessons learned. I mean, starting over is always tough, and every program, just the International Space Station is a fantastic example of the vast quantity of knowledge we learned from the Russians as we did the Mir missions and then moved into the station program. Being able to take those lessons and apply them directly to the way we were building space station systems and ECLSS systems and all that stuff, we bootstrapped ourselves way down the road. Same thing would apply as we move forward, right? The lessons of manned spaceflight are usually learned the hard way, and you wouldn't want to lose those. And so from whatever you can, extract the knowledge that's currently in the team and apply that forward would be the basic recommendation I'd make.
Sorry. No, go ahead.
I was just going to say something along the same lines. It is in the spirit of really trying to keep and understand the core knowledge, and then learn those things that are the lessons, the good and maybe the not so good, and then trying to figure out and apply them to how we can design for operability and design for simplicity and effectiveness.
Jason Ryan with Space Vidcast. This question may have been answered before, but I'm just going to check real quick. It seems like Discovery has chosen to fly more missions than the other orbiters. Now, is that because you guys are favoring Discovery for some reason, or is that just the luck of the draw?
I think Stephanie Stilson's the flow director, and she pays us a lot of money to put that one first in the manifest. No, it's just the way it works out. The manifest is I don't even know what word to use. Voodoo kind of comes to mind. The way you combine up the turnaround processing, the number of days it has to stay on the OPF, when a set of solid rocket boosters and tank are ready to go, the mobile launch platform, all the cranes that need to be moved. And so when you look at a manifest, what would seem like a simple answer as to which vehicle should be ready to fly next, it's never a simple answer. And just the way it's worked out, Discovery's gotten a good share of the missions.
Okay. We have some time for a couple other, if anyone has any follow-ups they want to ask. Here in the front.
Yes, getting back to the command carrier, would that be a carrier that would carry also a destruct system?
I told you as much as I've got with
Yeah.
regards to the
Yeah, I was
the
going to say
nature of the issue.
from what I recall from my my previous job, we use that for telemetry and tracking as a backup site, and the Air Force uses it as a range safety system, which would put it in that range safety system command category. And I think they also use it for tracking backup purposes.
Chris Gephardt with NASASpaceflight.com again. For the engine sensor issue that you had today, was that the advanced health monitoring system that discarded that sensor?
Yeah, I can't. I don't know the specific pedigree of whether that was a mod made for the advanced health monitoring or not. I believe we had those vibration sensors ahead of time. I don't know if it was 3 of 3 and it was the same voting scheme. But
I think the voting logic was part of the
think
advanced
that's a
health
new-
monitoring system, but we can confirm that offline. But I'm pretty sure it came about it in the sensor logic and deselect, I think, is some of the new logic that came as part of the new advanced health monitoring system.
And I kind of hate to shift focus away from 131, but I know you got some work to do at the pad, normal turnaround and safing operations out there. But where do we stand with Atlantis' rollover in terms of what date are you tracking for that one, and mating to the tank?
Well, right now we're the orbiter's in great shape. We completed the final orbiter power down, and we're completing the external tank and booster closeouts after having mated the external tank last week. And right now we're targeting rollover of the orbiter to the vehicle assembly building for stacking on the 13th of April, and then currently tracking towards rollout to the pad probably the evening of the 19th or early morning of the 20th of April.
Bobby Block again for Gerst. If you were to move to a shuttle-derived vehicle, heavy lift vehicle or moderate lift vehicle from here, how important is it that you need to keep flying the shuttle to make that transition smooth and affordable? Or can you stop and then go to a shuttle-derived vehicle later on reasonably?
Yeah, let me think. I think there's some real advantages if you can kind of keep moving from one system to the next. You know, we've got a plan right now as we've spent 2 years or 3 years building a transition plan to ramp down the shuttle program. It wouldn't make sense to restart all that stuff again, as we've talked before, unless that was going to get followed on and carried into another program. You know, you wouldn't want to go back and restart production in certain areas that we've turned off, restart subcontractors, all that stuff, if that wasn't going to be another future. So that's it's a different piece of your question. But if your vision is to continue on, then you might continue flying the shuttle. Is it necessary to go do that, or could you kind of stop and then start again? You can stop and start again, but it's difficult to capture the knowledge when you stop and then move forward. So as smooth as you can make that transition within the budget constraints you have, the better off you are.
Okay. We have time for one more question.
Thank you, Tarek Malik with Space.com and Space News for Pete. You mentioned how the shuttle launch looked, I guess, to you, and it is, I guess, the last planned one to launch at night. I'm just curious. Kathy talked it up a pretty good one over the last few days. If it met your expectations, surpassed them, what the team's feeling that the rest of them are all going to launch in the daytime. Thanks.
Well, to me, it was spectacular watching it from the control room. I was curious. I thought we might see, as the shuttle was going through through its ascent phase, that we might see some of the rays of sunlight on it. But I did not note that, as we thought it might have been the case. But still, every one of these launches are spectacular from my perspective. And we'll have to see. It's certainly at nighttime, it certainly lights up the Space Coast really well. But every one of them, you feel the rumble, and you just feel that excitement as that vehicle proceeds through ascent. So I know we enjoyed it.
Thank you. That's going to conclude today's news conference. To follow the STS-131 mission, stay tuned here at NASA Television. To follow us on the web, visit www.nasa.gov/shuttle. Thank you, and have a good day.